So for today, it just says that you're going to be able to describe the relationships between pressure, volume, and temperature of a gas when one of the three properties is held constant. So for example, these are your three kind of essential questions. What relationship do pressure and volume have when the temperature is held constant? So that means you're going to keep the temperature the same, but if you increase the pressure, what happens to the volume? Or if you decrease the volume, what happens to the pressure? So you're looking at the relationship between pressure and volume when the temperature is held the same. And then the other two are kind of worded similarly. It's just the different variables are interchanged. So on number two, what relationship do pressure and temperature have when volume is constant? So now you're talking about the size of your container is going to be the same. But if I, decrease the temperature, what happens to the pressure? Okay. Or vice versa. And then the last one is relating volume and temperature when you have constant pressure. Okay. And so what you're going to do is there is a online simulation that you're going to use to help you sort of work through this. So I'm going to go to the next page. You're using this, it's called a PhET simulation. PhET's the website. And so the H5P that's on this page, this is going to kind of be your notes, and it's also going to be your grade for today, similar to what we did last week on Thursday. So there's a link here, and then there's also embedded. So I kind of put it on here multiple ways. You can kind of choose which way you want to use it. So you can either click on this link and it'll open it in another tab if you prefer to have it open in a separate tab or a separate window, or it's embedded here as well. So you can click and it's embedded here in Canvas if you want to leave it here. And then below the simulation, this is your actual lesson. It's going to kind of go step by step. So you're going to click on, just like I did, click on the one that says ideal. Okay, the arrow is kind of showing you where to click. And then if you go here on page 2, it says add a couple pumps of gas. Okay, so I would go up here, and here's my little thing. I could add a couple pumps of gas. So it's putting gas particles into my container, and so I can see them kind of moving around, and I can see they're going to like collide with the walls, and then see they're just bouncing around. They're going to collide with other gas particles. Okay, and they're moving. And so when I go back down here, it disappeared. So you're going to hold your volume constant, okay? And when you have a constant volume, that means the size of your container is not changing. So they say, usually you'll hear words like rigid or rigid vessel, because that means that it's not flexible. That means the volume is constant, the volume is set, it cannot change. And so the gas, naturally, according to our kinetic molecular theory, gases are going to move and they're until they hit the walls of a container. And so they're going to fill up the entire volume of the vessel. And so if you have gas in a steel cylinder, like this one here, this is kind of like, looks similar to like those propane tanks that you might have like on a barbecue grill or something like that. This is something that would have constant volume. Other things would be like if you have a can of hairspray or, a can of any kind of aerosol container, that's in a contained volume. Even like a can of soda that's sealed, that's a constant volume. And so what happens is if you change the pressure or the temperature, but your volume is constant, if the pressure and the temperature increase enough, your container could burst. And so that's why a lot of times on canisters that are like aerosol cans or that have pressurized gas inside of them, you'll see on the label, it'll be like warning, keep away from heat, or store at temperatures lower than, and it has a temperature on there that says it shouldn't be in temperatures higher than that. And that's because, as you're going to see in your simulation, as you adjust the temperature, the pressure is going to increase and your volume, your container could burst. Okay. And then as you continue going through, it's just going to give you directions. So it says, like, look at the thermometer on the top. The default's going to be set to 300 Kelvin. And it's just reminding you what Kelvin is from our last lesson. And it's going to have you practice again with your temperature conversions, okay, from last time. And then it says if you cool it down below 0 degrees Celsius, the temperature becomes negative, okay? And then it's going to ask you questions about what do you see the molecules doing? Like, are they all moving at exactly the same speed at every time? And it's going to kind of go through, some temperature and molecular motion type of stuff. Then it's going to go talk about pressure, okay? And it's going to go through pressure and have you look at the pressure and answer some questions about how pressure and temperature are related. Then you're going to switch things up. So notice how it says part 2 now. So you're going to go back and you're going to change it to now the temperature is going to be constant. And it's got some information here. So if you have a constant constant temperature, an example of this could be a balloon, okay? The pressure can be changed, but the volume can too, because it's made of rubber. It's something that's not rigid, okay? And so this is where, you know, if you see over time, sometimes balloons shrink and things like that. But you can also, you know, you could take even like a basketball, you could put a basketball or a balloon like in the freezer and come back, you know, an hour later, and it's going to be, it's going to have shrunk because the temperature affects the volume at that point. You could also heat it up and it would kind of do the same thing. Again, here, it's as you go through, it's going to have you change some things. So again, there's some visuals here. So you're going to change like the volume by half. So it's going to have you shrink it in. Okay, there's a little handle here on the simulation. It'll have you shrink it, and it'll have you, you know, answer some questions based on that. Okay, so again, more questions, and then it's going to have you double the volume. It's going to have you double this and move the slider to where you're going to have twice as much space. Okay. Part 3, you're going to set your pressure to be constant. So over on that constant, hold constant menu, you'll change it to pressure. And then you can heat up or cool down the gas. You can increase or decrease the temperature and see what's happening to the volume. And kind of think about how does that relate to the kinetic energy that we talked about last week. And what is pressure? So think about the definition of pressure that we talked about last week. And then at the very end here, it has kind of a summary thing here. So if you have constant volume, you're going to drag some of these to kind of fit over here. If you have a constant temperature, you're going to drag some of these. And if you have a constant pressure, so you're going to drag and drop all of these different descriptions and pictures here under whatever correct area you believe they go under, and you can check. Okay. And, you know, this is a really good summary. It kind of summarizes all of the relationships between pressure, volume, and temperature. So when you're done, either you know, copy this into your notes, or if you want to take a screenshot to save it to add to your notes, you can do that. But I'd recommend, you know, somehow keeping the information, because this will be helpful for your quiz. Okay. And then when you get to the very end, make sure that when you get to this last page that you click the submit report and check, you can make sure that you've done all the interactions and all that kind of stuff on here. Okay.